Continuous integration pipeline in action. Real-world software development demo. Our project contains a proof of concept of a real-life continuous integration pipeline designed to demonstrate the same principles used in professional software development for cryptographic solutions. In the world of cryptography, a robust continuous integration pipeline ensures that every change to the code is automatically built, validated, and benchmarked, preventing costly errors and preserving trust in the final product. We've built our pipeline with CMake and CTest, running entirely in GitHub Actions. The stages are clear and structured. Build, test, benchmarking, and reporting. At the end of the pipeline, we generate the PDF graphs summarizing the performance and upload them as public artifacts. The technical documentation is also publicly available, making it easy for any developer to understand, reproduce, and improve the project. This isn't just automation. It's a blueprint for reliability in high-stakes software. Inside our artifacts source code, you'll find a YAML file, which is housed in the Workflows folder. This YAML file defines every stage of our continuous integration pipeline. The YAML file can be edited according to our readers' needs, allowing our project to be flexible and easy to integrate to already existing solutions. In our pipeline, we tested and benchmarked every experiment parameter individually. Our pipeline begins with a clearly defined build stage, followed by running our full test suite for each parameter in our experiment. After testing, we move into benchmarking each parameter. All these benchmarks are done independently and isolated in self-hosted runners, allowing us to get accurate results in a short time. At the end of every benchmark, the statistical results are uploaded as public artifacts. Once all benchmarks are complete, we gather these statistical results and run our graph generation scripts. The resulting figures are then uploaded, again as public artifacts. By making both the data and the graphs openly available, we ensure that other scientists can reproduce and validate our results. This openness not only strengthens the credibility of our work, but also reflects best practices in real-world software development, where transparency and reproducibility are key to trust and long-term impact.